Hello, I welcome you all to this another interesting screencast. The problem reads if force F is to have a component along the u-axis of Fu equal to 6 kilonewtons, determine the magnitude of F and the magnitude of its component Fu along the v-axis. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we are going to solve this particular problem by using the parallelogram, okay, as well as by resolving these forces in the x and y components. All right, let's kick the ball. Let's start. So one, we have the parallelogram, okay. We have the parallelogram method. There we go. Let's just underline. Great. So what we need to do is to draw the parallelogram. So we've already been given one force, which is Fu. So we have been asked to find the components of this particular force along axis U and axis V, okay, and also the magnitude of F. Great. So let's draw that. So we have the two child vectors. One vector is going to be this one. This one, okay. Let's draw it up to there. Then another vector is going to be this one. Okay, let's draw it maybe up to there. So we have these two child vectors. All right, let's name them. So this one is F equal to FV. This one is FU. Mind you, FU is already given. It's FU. Great, so let's draw the parallelogram. So we have another vector here like so. Okay, maybe this one is a little bit long. We'll make it longer. So we'll have another vector like so. They are like this. Okay, something like that. Okay, let's make this a little bit longer. All right. There we go. Take it up to somewhere there. Right. Then we'll have another one in that direction like so. Okay. Can we just move this a little bit? We move it down. Assuming I'll be able to move everything. Great. All right, it has moved down. We make this a little bit. It goes a little bit up again. All right, something like so. Okay, there we go. Then we have this maybe a little bit longer like so. All right, this one, let it go up again. I just want it to look as close as possible to a perfect parallelogram. Not bad. Okay, so we have two triangles on top and down, and they're all the same, and I'm going to use the top one. It doesn't matter which one you use. So like we said, this is Fu, and mind you, Fu is already given. This is Fu, and that's FV, and this one here is FV, and this one here is FV, and then this one here is Fu. So let's add more details to this. What do we have? we know that this angle here, this one here is going to be equal to this one is going to be equal to 105, right? Okay, is 105, and then we have this one here. This one here, the total angles in a triangle is 180. Therefore, we subtract 180 minus 105 minus 45. This gives us 145, and 105 is 150. Therefore, this is 30. So this one here is going to be 30. Great. So we have everything that we need. So which one are we going to use between sine rule and cosine rule? So we have Fu, and we have the angle. So we are going to use sine rule. So we have sine rule, I think, is better. Let's go for sine rule. So let me say Fu here is already given, is equal to 6 kilonewtons. All right, so let's start. So say sine 105 divided by Fu equal to so this one here, this is our resultant. This F is equal to F resultant, right? Okay, so this is going to be equal to sine 30 divided by FRR. Okay, therefore FRR, which is equal to F, is just going to be equal to FRR, which is equal to F, is just going to be equal to Fu sine 30 divided by sine 105. Okay, therefore FRR is equal to F, which is equal to let's do the calculation. So we have 6 sine 30 divided by sine 105. So this gives us a 3.11 kilonewtons, right? Let's work it out again. That's 6 times sine 30 divided by sine 105. Okay, so then the next one is sine 105 divided by Fu equal to sine 45 divided by Fv. Fv therefore is just going to be equal to Fu sine 45 divided by sine 105. Fv is just going to be equal to 6 sine 45 divided by sine 105. Alright, so we have a 4.39 kilonewtons. So we are done with the first one using the first method. Let's go and resolve the forces in the second method. Right, So here we want to resolve forces. This is the second method. So we resolve the x and y components. All right. Okay. Those are axes. All right. So let's draw our axis. So let's say this is our y, this is our x. Let's write them down. Let me just clean this point here. All right. So this is our y, this is our x. All right. So let's say we have these components there, these child vectors along those directions. So let's say we have this one, and then we have another one along the u vector like so. So these are child vectors. So let's call this one as Fu. Let's call this one as Fu, and then we call this one as Fb. Okay. So now let's distribute these, and then this one we'll call it as our resultant, Fr. Alright, so let's distribute this. Fu is just a single component along one direction along the y. Fu will have two components. So Fu, it will have one component along this direction, and then it will have another component along this direction. All right, then Fr, it will have also one component along this direction, and then it will have another component along this direction. Okay, let me just, okay, I can put it also here, it's fine. All right, so let's just label them. So this is F, this is F, this is F. This angle here is equal to, this angle here is 90 minus 45, so this is 45, and then this one here is equal to 45 minus 105. This gives us a 60. Okay, great. So this is just going to be equal to F cos 45, and this is F sine 45. Can be the other way around because it's our 45. And then this one is just Fv sine 60, and then this one is Fv cos 60. Okay, let's draw a table. So we have force, we have the x component in kilonewtons, right? We have y in kilonewtons, excuse me. So let's draw a table quickly, like so. Okay, how many do we have? We have 3 of them. All right, let's fill it in. So we have FU, we have FV, and then we have FR. Okay. So FU along the x-axis, FU is 0. Along the y-axis, it is FU. FV along the x-axis, it is FV cos 60, and then along the y-axis is minus FV sine 60, and then FR along the x-axis, it is just F cos 45, and along the y-axis, it is F sine 45. So we have everything. So the equation is Fux plus Fvx is equal to Frx. Alright. Okay. And then the other equation this side is Fuy, plus Fvy is equal to Fry. So there we have a 0 plus Fv cos 60, which is equal to F cos 45. Okay, maybe I write down somewhere. I write down this up. So using our first equation, let me write here where I have space. So I have a 0 plus, so I'm using this equation. Okay, I have a 0 plus Fv cos 60 equal to F cos 45. Fv therefore is just equal to F cos 45 divided by cos 60. Okay, then the other equation, using this equation, we have Fu minus Fb sine 60 is equal to F sine 45. Then we are going to plug in this equation here. Okay, when we plug in this equation there, therefore we find that and then we know that Fu is equal to 6 kilonewtons. Alright, so we'll find that our Fv is just going to be equal to our F R, or just our F, which is equal to Fr, is just going to be equal to, let me just move it down, our F which is equal to Fr is just going to be equal to, grab your calculator. Alright, so we have cos 45 divided by cos 60 times sine 60. goes the other side, then plus sine 45. Then we have 6 divided by answer. So we have a 3.1058 and so on. We round it off to just 311 kilonewtons. Alright, so with this information we plug in. Here I'm plugging it again. I'm plugging in a full answer here. I'm plugging in 6 divided by, see, because I have it on my calculator here, I don't want to plug in the rounded off value. So this is sine 60, sorry, this is cos 45 divided by cos 60, then sine 60 plus sine 45. So this is what I'm plugging in. Okay, this is what F is. F is equal to that. Okay, alright, so this is what F is equal to. There, that is what we are plugging in. We are plugging in that value there. So we say that's cos 45 divided by cos 60 times sine 60 plus sine 45, 6 divided by answer, and then we plug it there. So we plug it here. Want to plug this in this equation. So let's plug this there. Okay, and once we plug it in there, we'll say times cos 45 divided by cos 60. Alright, then we'll find that our FV is just equal to a 4.39 kilonewtons. Okay, great. Great. So there we go. We have found everything that we need. In the first case, we have FR which is equal to F, and then we have FV. Okay. In the second case, we have FR which is equal to F and FB using two methods. Alright, I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.